Hi, Lamai. How are you? Hello. Can you hear me?
Yes, sir.
Okay. Mm-hmm. Okay. We have completely finished force, now finished momentum, and going to do some kind of exam related questions, including exam type questions, term test questions, completely today. I don't know the So, in yesterday, there was a student who joined to my paper class, 2024 paper class. Unfortunately, she had really big problem. She got only 5 answers correct out of 15. But in my students, there were like 3 students could score 15 out of 15 in the paper class. The reason is they have just practiced a lot about what questions during the class, even before the beginning of the paper class. During the class, I give you guys really good amount of question practice. And today itself, another student, my past student in this class, she is no more in this class because she had like an eye problem. Doctor has just asked her not to watch TV even. Visudama. So she had to leave, but a really good girl. I asked her what is the current lesson she is having in a physical class in Candy. She has just done equilibrium of forces. Equilibrium of forces for so far. So that's why I told you for most of the classes, we are bit ahead already. But only very handful of classes are just a bit above us. Very handful, but most of the classes are very lower than us. So we are in a really optimum speed. No need to force ourselves and really hurry up the process. No need. Because we are already currently in the right path and current phase, proper phase. So there is nothing to worry about in that content. ඉතින් අද ප්‍රශ්න ටික කරද්දී තමන් දන්නවා මෙතන ක්ලාස් එකේ මේක විතරක් නෙමෙයි 24 23 ඔය හැමෝගෙම questions කරන දවසට ළමයි පොඩ්ඩක් එන්න අදිමදි කරනවා. නම්බර් එකේ හරක්ක මට උඹෑ කියලා සද්දෙත් ඇහෙනවා. එයාලා හිතන්නේ theory විතරක් ඉගෙන ගත්තාම ඇති කියලා. Those who just thinking like we learn the theory, that's enough. But unfortunately that is not enough at all. theory එක විතරක් දැනගෙන අපිට කරන්න පුළුවන් ඉටි ගෙඩියක් නැත. So we have to have a proper practice of the paper of all these questions. හරිද? ඒ practice එක ඔයාලට තනියෙන් ගන්න පුළුවන් නම් ඔයාලා class එන්න ඕනත් නැහැ. එහෙම බෑ. So during the question discussion in the final day of the lesson, question discussion you have to. In the next week we are going to start energy, work, energy and power. After finishing that one, we have a really huge amount of questions that we can do. Because there is a very big problem here for us to do. That thing is, we have a very low amount of question capacity. The reason is we have to deal with what? We have to deal with very low amount of knowledge with us. Because once we complete energy and power, that knowledge, our knowledge capacity for this lesson is almost like complete. Can you guys really hear me well?
Yes, sir.
Hello?
Yes, sir.
So today itself, we are going to test our good knowledge. Question discussion is something really must do thing. So, what way would you like? Do you like me to discuss the questions in this board, or quickly drop a message? This board for a virtual board for B. Well, I will consider with the majority of the message count. This board A, you can type like this board, whatever, it doesn't matter. ඔයාලා වැඩියෙන් කැමති මොකක්ද ඒක කරමු. B4, yeah. A4 this board, this. B4 graphic tablet. What is your board you would like? The graphic board or this board for discussion of the questions? අග්ගල දාන්න. හැමෝම දාන්න ඉක්මනට තීරණයක් ගන්න ඕනේ. Okay, one said A, one said B, again another said B. 2B, 1A so far. 3B. Quickly. Others, everybody. I need everybody's opinion. Another B. Okay. More than half the students already voted now. There are 2 to 3 votes. So for in the Novia land. Taggal again. Another one said B. 6B, 1. Hey, there is one student who didn't voted so far because it's supposed to be according to the count right now. Two of these heads are me, no? So only 8 heads outside. So outside of the 8 heads, one guy or girl somehow didn't know what. Hari. Oh, Mari Kamarne. By the way, I want to know one thing. How is the paper class you see? Is that really productive for you? Are you ready for taking the paper class? So shall I start very later? නැත්නම් ඔක මාස 4-5ක් ඕක නවත්තලා තියලා පස්සේ පටන් ගන්නද? දැන් මම ඔයාලාසන වැඩි වගේ හිතනවා නම් if you think like it is really better, I can continue. I'm asking about the paper class. සමහරුන්ට හිතනවත් දන්නේ නැහැ early වැඩි කියලා එහෙම ප්‍රශ්නයක් තියෙනවද? ටක් ගාලා කියන්න හැමෝම. Tell me. To Taridu Physics Unlimited thing you have to say. Is that the paper class really valuable? Oh, just bullshit already. But one said like it's very effective. Others? Okay, really valuable. Let's continue. Okay. Others? Okay, 3 said really valuable. Others? Very productive. The others? Good practice. Sorry. Okay, enough. So finally, we are going to start this set of paper discussion. Not paper, actually the amount of question discussion. Are you ready for these questions today? Let's move on to other board and quickly start that. Okay, are you ready? Are you ready? Say okay or no. Whatever. Ready? Great. Let's start.
Hi everybody. Can you hear me? So the questions are kind of tough. I'm not talking about these questions are really hard. Uh, these questions are really the basic, right? It says like, uh, 1 minute, please. It says like a 2 kilogram block is released from rest at the top of a curved incline in the shape of part of a circle of radius r. The block then slides into a horizontal plane of finally comes to rest at 8 meters. Okay, distance of 8 meters. Right. It says like the circle. So part of a circle. You have to remember this is R. This one is also R. That means height is equals to R. Got it? The perpendicular height from here to here is R. The block then slides onto horizontal plane where it finally comes to rest of like 8 meters from the beginning of the plane. The curved incline is frictionless, but there is an 8 Newton force of friction on the block while it is sliding horizontally. When it reached to here, it is not free moving, it is moving under the frictional force. Under what? Frictional force. Right. The friction is always F equals to 8 Newton in the opposite direction. Determine the magnitude of acceleration of the block while it is sliding along the horizontal plane. You can easily obtain because you know the mass. It is m equals to 2 kilogram. F is equals to ma from Newton's second law of motion. Acceleration equals to 8 over 2. It is like 4 ms minus 2 negative because it's a deceleration. Understand that? Can you understand? Yeah. Okay. So there is a thing asking about. So please again. Okay, I will explain you. It says, Lamia, the mass is 2 kilogram and the resistive force is 8 Newton. So the force, you know, it is resistive force of minus 8 because opposing the direction of motion because the block is trying to move to here, but the force is applying in the other way, right? In the negative direction. So if it is applying on the negative direction, that suggests strongly the force is a negative one. So according to Newton's second law of motion, F equals to ma, acceleration equals to force over mass. So the force is minus 8 divided by the mass of 2 kilogram. Your acceleration is minus 4 m is minus 2. Understand? I explain that again. Okay. How much the time elapsed from sliding horizontally? Right. We know another thing. H equals to ut plus half at square. So the thing is, we don't know u, so you can't use it. There is another way. V square equals to u square plus 2as. You know that v should be 0. You can find out u from here. U square is equals to 2as. U is equals to 2as. So 2 times acceleration you just found 4 times the displacement is also 8. You finally find u equals to 2 times 4 is 8. 8 times 8 is 64. Square root of 64. That means u is 8 ms minus 1. How to find out now time? Because you can apply v equals to u plus at. We know the velocity equals to 0 now. 0 equals to 8 minus 8. Sorry, the acceleration is 4. Sorry, 4 times t. This 4t goes to the other side. 4t is equals to 8. T equals to 2 seconds. It is very easy. I hope you can understand how did I arrive at this answer. If you are really not comfortable, you can ask me. I can explain you properly. So decision is up to you. Understood or no? Ramai, I will not asking repeatedly the same thing. Before I used to ask you repeatedly. If you don't understand, you have to ask. I will only wait like 10 to 15 seconds only by asking, could you understand? If you don't ask me, repeat it. Sir, can you explain it again? I didn't understand this part or something. I'm not going to ask you again and again. It is a wastage of time. Okay. If you have any problem, I can explain you. So remember that I won't repeatedly ask. Now ask the calculate the radius of the incline in meters. Oh, so there is a very big problem now. Why? Diameter. See, the block then slide onto the horizontal plane where it finally comes to rest 8 meters from the beginning of the plane. It is given. ඇස්පේන දිවරස්නයක් එක තියෙන. That is a problem regarding your eyesight. නේද? So this one is a future lesson. Next week lesson actually. There is a thing called conservation of energy. You have to use it. Right? Okay. But there is another bypass method here. According to that bypass method, if you are really wise enough, you can understand this is a what frictionless surface. When you consider the motion vector, height factor change is a vector along according to gravity. It is falling due to gravity. So there is a y x direction motion, but gravity is only affecting y direction. I'm telling you some vector method, but the simple method you will learn in the next week, law of conservation of energy. But I'm telling you with the previous methods, you can just take the vertical height as the final vector of the y-axis. So the height, you know, it is the r, sorry, asking about r, you have to find it. Acceleration, you know, 10. So the velocity you just found, it was 8, you know, and the So initial velocity while releasing here, u should be 0. We have these results, so you can apply this into v square equals to u square plus 2as according to vectors. V is like 8 to the power 2 equal to 0 plus 2 times acceleration of 10 times r. So r is going to be like 64 here. 64 over 20, that is 3.2 meters. Can you understand this? From your very earlier knowledge of vectors, the resultant vector downward is just this radius because it is radius. I told you this is radius. This one is also radius. That is the same height here. Ane? This is only valid if it is frictionless, otherwise not valid. It says frictionless. So you can just use your knowledge of vectors. If not satisfied, don't worry. Once we done with the next week, you will learn potential energy equals to kinetic energy. Next week thing, huh? This is not something you learned so far. So you can apply this one and find the answer. Don't worry. I'm showing a certain trailer for the next week. Right. The next one. A 10-kilogram block is pushed along a rough horizontal surface by a constant force F as shown above. A constant force, right? At time equals to 0, the velocity of the block is 6 meters per second in the same direction as the force. The coefficient of sliding friction is 0.2. Gravity is 10. Calculate the force necessary to keep the velocity constant. The force is now changed. The large constant of value of dash. The block accelerates, so the kinetic energy increases to 60 joule while it is slides a distance of 4 meters. Okay. There is the first part here asking like calculate the force. You know one thing, the weight is mg. That is the R reaction. So we know the frictional force is equals to mu R and we know R equals to mg. So the frictional force is mu mg. So mu is like 0.2 and the mass is 10 and 10 is like 2 times 10 is 20 Newton. If you provide that frictional force, certain force equals to frictional force, you can have a constant velocity, right? You can maintain it at a constant velocity if you just provide the frictional force. Can you understand? Otherwise, friction will slow this down and stop. According to Newton's first law of motion, if you provide certain force that is equals to the opposing force of frictional force, this can have two scenarios. That first one is stationary, stop. The second one is moving at constant velocity. Here it is moving under constant velocity under equilibrium of forces. The forward force will be equal to the backward force. Understood? Okay. Now it asks here, see, if necessary to keep the velocity constant, that's found, the force is now changed to a larger constant value of F1. F dash, the block accelerates to gain kinetic energy of 60 joule when it is moving like 4 meters. Okay. If you remember your grade 10, you can do. If you don't remember your grade 10, you have to wait. Understand? For the next week. I'm showing a certain trailer for the next week. according to your grade 10 knowledge, when you apply a certain force of F along certain direction on a certain object, so the displacement traveled is just D here. If you can remember this equation in grade 10, work is equals to force multiplied by displacement. Okay. So in the other way, W equals to FD. Got it? So the work is force, I don't know, the energy gain is equals to the work. 60 is the amount of energy gain. This is the amount of force that you don't know F dash. And the distance traveled is 4 meter. F dash should be 15 Newton. It is 15 Newton. Okay. So the total force should be bigger than this. The total force should be, the F dash actually bigger than Y. This is the resultant force. Resultant force. Actually, F dash should be even greater than this because you have to add this 20 Newton and this one together. Real F dash is 35 Newton. Got it? Now you have to find out the acceleration of the block. The difference of the force is here 15. 15 equals to 10 times acceleration. Acceleration is equals to 1.5 ms minus u. So if you don't understand any of these parts from here, wait, if you don't understand anything from here, that means your grade 10 knowledge is very weaker. So wait for me to teach in the next day. But in that day, please make sure you learn things really very carefully. Understand? Okay? Boy. It says like third lesson. This is long way from here. මම මේක කරන්න මේපා කියලා කියන්නේ because you don't know how to do it. It is the simple harmonic motion, our next main lesson. We are in the mechanics now. Our main lesson is going to be simple harmonic motion. It will take at least like another 3 to 4 months from here. මාස 3-4ක්වත් යනවාම තමයි. So don't do part D, but do part A, part B, and part C you can do. Then you can try the fourth one. Fourth question is a very long one. Fourth question is a very long one. So my time allocation is 12 minutes. මොකද ඊට වඩා දෙන්න ඕනේ නම් තමයි. මොකද කරගන්න බැරි වෙන අයට ඩල් වෙනවනේ. මේ මොකද්ද මේ මට මේක කරන්නත් බෑ කියලා. So the maximum time allocation is 12 minutes for you. Your timer starts now. It is question number 3 and question number 4 that we have to do. Okay, guys? Let's start. Hi, Ramai. How do you think? Do you feel like needing more time more? Yes, shall we just start off with? Huh? Ramai. Hello, Ramai. Hello. Stuck at the last part of question 4, sir. Okay. Didn't finish yet. That means do you need kind of more time, like 1 or 2 minutes? Huh? Let me know, Ramai. Better explain. I think it's better for I'm doing deep part, sir. Explain. Sir. Whatever it is. දැන් මගේ අනිත් කට්ටියකෝ මගේ ඉන්ට්‍රෝවර්ට්ස් ටිකකෝ it stops explain. Okay, no problem. Hi guys, can you hear? Is that my voice kind of glitchy and laggy? Not laggy. Oh yeah, not laggy. Okay. An ideal spring, unstretched length of 0.2 meter is placed horizontally on a frictionless table as shown above. One end of the spring is fixed and the other end is attached to the block of mass 8 kilogram. The 8 kg block is also attached to massless string that passes over a small frictionless pulley. A block of mass m equals to 4 kilogram hangs from the other end of the string. When this spring and block system is in equilibrium, the length of the spring is like 0.25 meter and the 4 kg and 4 kg block is just 0.7 meters above floor. Okay, this one has an unstretched length of 0. At the beginning, it was like this. This is 0.2 meters. At the end, it is 0.25 meters. So what is the length change? Change of length is delta x is 0.25 minus 0.2. It is 0.05 meters. You have to get that one. Okay. For the future result. So you have to get this result here. Now it is asking on the figure below, draw free body diagram showing labeling forces at on each block when the system is in equilibrium. Here, I will mark firstly on here. You can see now mg is downward and the reaction force is upward. So there will be a certain force of what? tension T here, and the friction, the force from the spring here, F. Now what I have to mark is the reaction force, Mg, and tension, and the spring force, S. You have to mark it like that. In the right hand side, the 4 kilogram thing, it is only having the tension upward and the 4G downward. I just mark it like 8G here, 4G downward, and the tension upward. And I hope you guys understand this. Can you understand what did I do here? Yeah, clear. Now from the first box here, the left hand side first box, you can get it like the tension in the spring is going to be like the same force as here because it is horizontally in equilibrium. Considering horizontal equilibrium, the thing it is going to be Kx. You don't know that. Wait. Tension in the string here, not the spring. You can use actually the vertical. This one, sorry. This one. Considering vertical equilibrium of 4 kg block. Have a good look at here. Tension equals to 4G. Tension is directly equals to 4 by 10. It is 40 Newton. Very simple. Now calculate the force constant of the spring considering horizontal, equilibrium of 8 kg. Now it is going to get balanced by this T force because of Fs is the same. Since we know the spring force is Kx, so it is Kx is equals to 40 Newton. $800 Newton per meter. Did you get these answers? Check whether you got these answers or not. නැත්තම් කියන්න එක අවුලක් නැහැ. Okay, your 15-minute of waiting time over because I told you I am only giving you 15 seconds of waiting time for your responses. Nobody said me anything about they can or can't, so I assume that everybody can understand. තප්පරපාල ඉවරයි ගොල්ලෝ. බවුන්ද කියලා දෙන්න. Look at this 8 kilogram block. It is vertically balanced by R and Mg. It is balanced. In horizontally, it is not accelerating to any direction. That means there are only two forces. This tension should be equals to spring force. And we know one thing, in a spring, when you supply certain force of 0, extension is equals to 0. When you add some force of F, it will get some extension of delta x. So the F force is equals to minus kx. This is a very long time lesson, like almost like 3 weeks ago I taught this. So this is the spring constant. X is the change of displacement. Here it says like original length of 0.2 meter. So x final length of 0.25 meter. So the delta x extension, it is 0.25 minus 0.2, it is 0.05 meters. Okay. Now you can divide this value 40. Tension is 40, we know. 40 tension is balanced by the spring force. X is K equals to 40 over X. That means 40 divided by 0.05. That means 800 newtons per meter. What did you say? I am not attending this class, but I can understand this. What did you say, Navisa? Can you speak up and say? I can't understand what you are talking about. Navisa, at least like a text. Ah, yeah, you joined in this month, but still you can understand this, no? Yeah, these things are not really hard. Very simple things. I told you, never ever think of this fourth part. Now we have to think of the third part here. Calculate the force constant of the spring. The spring is now at that point. We just found force constant. So here, don't do it. I told you, don't do it. Kind of really tricky question here, but it will cover entire knowledge you want for the forces and the friction. It is like Final Destination type of question. Have you ever watched that movie series called Final Destination? බලනද ටිකක් පරණයි. Older like some 16 to 17 years, but it's a really good series of movie. Roma film set. There are like people who get like certain rescue from accidents. They have to die. They just skip this by some by chances. Death coming after them. It is like a very scary things to there. So there was a certain scenario like this. The driver was just applying brake. There was a kind of very big concrete stuff there. The concrete thing ran over the driver's chamber and he died. Okay. Now it is like for a 4,700 kilogram truck carrying a 900 kilogram crate traveling at 25 meters per second right along the straight level highway as shown above. The truck driver then applies brake as shown, slows down. The truck travels 55 meters in the next 3 seconds. The crate does not slide back of the truck. Okay. It does not slide. That means it is not the scenario like that. Final destination. Okay. Calculate the magnitude of the acceleration of the truck, assuming it is constant. On the diagram below, draw and label all the forces acting on the crate during the braking. R is there, mg is downward. So the F equals to ma force will be there. අපි දන්නවනේ brake ගහද්දි ඉස්සරහට විසි වෙන්නේ කියලා. Frictional force is backward. These are there. So now we have a good look at, so what to do, calculate the magnitude of acceleration of the truck, assuming it is constant. Okay, so it says like it is moving under some 25 meters per second. The truck travels some 55 meters in next 3 seconds. Okay, that means, so you have to find it out like S equals to UT plus half AT square. You have to apply to here. S is like 55 meters, U is 25 plus half A you don't know, T you know, UT, okay, sorry, මෙතන දාන්න and T3 to the power 2. 55, 75 plus 9 over 2. Okay. Huh. I'll have to bring this one to here. It's like swapping the numbers. 9 over 2 minus 9 over 2a is equals to 75 minus 55. This 25. 9 over a 2a equals to 25. Sorry, 55 minus, sorry, 20, only 20. So acceleration equals to 20 by 2 over 9 negative 40 over 9. So acceleration can be like, how many 9s are there in 40? It is like 4 point minus 4 point again 4 repeated, no? It's like repeated ms minus 2. Can you get this answer? Do you get this answer? Do you guys get this answer? Very, very simple question. Calculate the minimum coefficient of friction between the crate and track to prevent the crate from sliding. Okay, so you know that there is an acceleration here on the block. Due to that block, it is trying to move forward. So according to Newton's first law of motion, if it is, there is no relative motion. Here the between the block and the lorry or the truck, there is no motion. That means it is in the equilibrium relative to the truck. Relative to the ground, the both truck and the crate are moving, but relative to the truck itself, this does not move. That means it is under Newton's first law condition. Understand? සමහරුන්ට ඕවා තේරෙන්නේ නැහැ. ඒක නිසායි මම මෙයා I'm repeatedly asking you again. Can you understand this thing I mentioned? The truck is moving, and with the truck, block is moving. Relative to someone outside, they can move, the truck and block are moving. But someone with the truck, does he see the block is moving? No. Okay. There is the force of MA here for this part. Force of M is here. M 900 times 40 over 9 is equals to the mu R, mu mg. R is mg, 900 times 10. 100. Maybe the gap 1 0 will cut off from here. Because මං solve කරන්නේ මට හිතෙන විදියට ඔයාලට ඒක තේරෙන්නේ නැත්නම් ඔයාලට පුදු විදියකට කරන්න ඒක අවුලක් නෑ. So the again 0.44 enough. 0.44 stop. There is no unit. Indicate whether this friction or static or kinetic. Now the truck is moving. Now tell me whether this friction is static or dynamic. Tell me. I told you there are two types of friction. One is static friction, other one is dynamic friction. Tell me whether this friction is static or dynamic. Kinetic. Okay, guys. It is definitely static because block is moving relative to the ground. Can you remember the definition of the friction? It is saying the force acting against what? Relative motion between two surfaces in contact. These two surfaces, the block surface and the truck surface, they are not moving relative to each other. So here this definitely static, not kinetic. Okay. Now assume the block of the truck is frictionless. Bed on a truck is frictionless, but there is a spring of force constant 9,200 Newton meter is attached to it. The crate to the truck as shown below, the truck is initially at rest. If the truck can brake now, make it brake making on the suspension bar. If the truck and the crate have the same acceleration, then calculate the extension of the spring of the accelerate. Okay, rest to 20. Okay, rest from 20 meters in 10 seconds. You have the same acceleration. Previously, you got acceleration of what? 4.44. Yeah. I use like 4009 for my convenience. Okay, now it is in 10 seconds. So let's find out this acceleration. (2.5 ms minus 2). It says like the truck have the same acceleration. Calculate the extension of the spring from rest to this much in 10 seconds. Not this one, different acceleration now. F equals to kx. So F equals to ma, you have to equal these two. Kx is equals to ma new extension x equals to 900 into 2.5 over the k. What is my k constant here? I found no, it's given here. Sorry. Nine times 2.5 over 90. 9 times 2.5 over 90. I will just leave it like this. That's enough. හරි. මොහොතියම නැත්නම් ඔබ solve කරන්න හරි අමාරුයි. At sometimes later, the truck is moving at constant speed of 25 and the crate is in equilibrium. Indicate whether the extension of the spring is greater, less so, same as in part what? Oh shit. There is a big miss here. So the what part is not given. Part is like part B or part C. That's a problem associated with the question. That's why you guys couldn't do it. Uniform velocity means it is definitely unstretched. Unstretched means it's like definitely original length, maintaining original length. If it is compared to the previous one, it will remain at the previous status back. So it is again like mostly like rather than D, same as C. The problem is when the truck was accelerating. So මෙතන ප්‍රශ්නේ හරියට අහගෙන තින්නා මේකට එන්නත් බැහැ. Okay now. Now there are many spring related questions we have done. So try the question number 5 at home. So you may get the similar thing. ආපහු බොරුවට එකම කරන්න ඕනේ නෑනේ. Let's move into a new part here. But this one is also spring related. But the thing is, it is somewhere you have to think of like momentum. Okay. After that, the term test things. I want you to try the term test things. So let me check the timer. It is 9:24 yet. No problem. We can try these two questions. So now try the question number 6 and 7. I'll give you 10 minutes for you. Sorry, 12 minutes. Your timer starts now. Hi, Ramai. Hello. Can you hear me? Can you hear me? Is that kind of like lagging or clear here? Yeah, very good. Now the questions are here. V naught, it is moving from V naught from some capital H height. A block of M1 travels horizontally with the constant speed and V naught. Actually, it is V naught here on a plate at plateau at a height of capital H until it comes to a plate and toboggan of mass M2. Here it is M2 is positioned on the ground level of a cliff as shown above. The center of the toboggan is the distance d from the base of the cliff. Determine the d in terms of V naught, H and G that the block land on the toboggan. If it is landing on here, so you know that the displacement is capital H and it is constantly getting acceleration of G equals to 10. Initial velocity downward is 0. Finally, it may reach to something I don't want to. So the time it will be completely determined by the vertical motion downward. the vertical motion downward. The horizontal motion has nothing to determine the time. Right. So we can find out the time using S equals to ut plus half at square. So u is 0. H is equals to half g t square. The t is going to be 2h over g and the square root of it. You can just keep it like number 1. Now it says like determine the d. You know one thing, velocity horizontal will be v naught and it is constant and it will time travel under the time of t because we know that velocity equals to displacement over time. So the displacement equals to velocity into time. Right. So you can determine the displacement now. How? D is equals to v naught times 2h over g. This is it. Okay, I hope everybody got the answer. If you have any problem, you can ask me. I'm waiting for 15 seconds from here. Now I think the 15 second is almost over. Gamai, do you have any problem? Hello? I think no. The block stitched toboggan, which is free to slide without friction, determine the resulting velocity of the block and the toboggan. Because now the block and this block can denote M1, M moving with some velocity, common velocity of v. But initially, only the block had the horizontal velocity. Now you don't want to consider about vertical velocity because it is not vertically moving down. It's all about horizontal velocity. Vertical things, we don't care. I told you, in the last week, can you remember? According to the definition of law of conservation of momentum, I said you have to take always according to a certain direction. And I told you I kind of forgot to add the direction thingy. Then again I said to add. Right. According to law of conservation of momentum along horizontal direction. Initial. P initial. What is it? M1 times V naught. What is P final? M1 plus M2 and the common velocity, I don't know. Right. Now what should I do? M1 V naught should be equals to M1 plus M2 times V. Right. V is M naught V naught over what? M1 plus M2. Very simple. It's not a big deal. But lazy. It's very easy. Not just easy, very easy. I hope you understood. I'm just waiting for another 15 seconds. If you have any problem, I'll explain you. Otherwise, I'll keep moving. 15 seconds is over. I'm going to explain. Before collision, it is moving with some 2m mass with velocity of v0 towards certain mass of capital M there, where it is locating some x0 displacement. After the collision, it is just moving from some x from M. A block of mass capital M is resting on horizontal, frictionless attached to an above relaxed spring constant K. A second block of 2M and the initially V0 collides with stick to the first block. Develop an expression for quantities in terms of M, K, and V0. Okay. Right? So you might be really disappointed today. Why? I didn't give too much of numerical questions, no? Numerical, but algebraical. The reason is in the A level, you have to form so much of algebraical relationships rather than numerical values. So this is a good start. I didn't add too much of numerical questions before. Now it is the time to make you train to the next level. You know that I always pull the trump card at the right time. This is the right time for you to get the proper training for algebraical version of mathematical applications in questions. I can give you very simple numerical value things, but if it is not helping you in your exams, useless, no? Right. A block of mass M is resting on horizontal and frictional attached to the explain K, and the block of 2M is going in stick to the first block, and develop expression in terms of M, K, V, and V0. Speed of the block immediately after V speed of the block immediately after the impact. Okay, it is like the M1 V1 equals to M2 V2 the model. I told you don't remember this model because this model is not exactly identical. So now for this connection, 2M and V0. Here the connection is M2 is 2M plus M times V. We don't know V. It's like 2M V0 over 3M. M and M cancel off. Velocity will be 2 over 3 V0. Very simple. Now the first part is done here. The second part is x the maximum distance that the spring compressed. Okay. So we know one thing. X so the kx degree, we have to come up with something called energy. So the F is kx. So we know energy equals to F into displacement of x. In that sense, F is kx, kx to the power 2, and actually this is starting from the higher force to very low force equals 0 to force equals to very maximum value of F. At the beginning, there is no spring force, no. At here, the maximum force. So you have to divide it by 2. This is something you may really see. How did he do? Don't worry. I will explain to you this in detail, definitely not in the next day. Like 2 weeks from here, you will get to know this theory in detail. In detail. Okay. So I will stop further explanation from here because I didn't teach you the law of conservation of energy. Law of conservation of energy. You only know law of conservation of momentum so far. Energy, you have nothing. So I stop this one at here. I am showing a trailer for the next week. This is a trailer of the movie that I am going to show in the next week. Okay. Right. So this one also something similar to that. So you to try this one at home. I will leave it for you to do at home. So now let's take an interval of 10 minutes and just get a quick refreshment and come back and let's do the term test question here. Term test questions tika karala. Right, interval.